Thank you for the lovely introduction, Greg. Really appreciate it. As you said, yep, I'm Lori Glaze, and I'm so excited, really excited to get to talk to you this year in this new capacity as the Acting Deputy Associate Administrator for ESDMD, the Exploration Systems Development Mission Directorate. And as Greg said, I do really want to apologize for not being there in person. I can't even tell you how much I was really looking forward to seeing everyone there this year. But as Greg said, the weather foiled my travel plans, and I figured it was better to get back to DC so that I could do this virtually than not at all. So so that was the path I had to take. I'm really most disappointed that I didn't have the opportunity to attend the student networking lunch. I can just only imagine the energy and excitement for this group of students with the moon landing becoming, not just history, but, the future's here. It's unfolding right in front of you and in front of all of us. So before I share some of the latest details on Artemis, I did want to say how really pleased I am to be joining my colleague, Dr. Gina DiBraccio, who took over the reins for NASA's Planetary Science Division when I began my new detail just a little under 2 months ago. And I can tell you it's a daunting task to take on the Planetary Science Division. I've got firsthand experience, and she really stepped up, and I know she's doing a great job. She's an amazing leader, and really excited to get to present with her together today. I also, before I jump in, wanted to just quickly acknowledge last week's announcement on Viper, which I'm pretty sure was discussed yesterday. And I just want to say that, while the measurements of Viper are certainly of interest, those types of measurements are of interest to ESDMD. It is a Planetary Science Division mission, and I just wanted to kind of set the expectations up front that really, I want to make sure Gina has the opportunity. She's really best able to address any lingering questions after our talks there, but we can certainly go there and talk about it. If I could have the next slide, please. So my talk today is really going to focus on NASA's Artemis campaign and the many ways that it blends science and exploration. As we all know here, we all believe science and exploration really are two sides of the same coin, and together they really drive discovery and innovation, ultimately creating new knowledge and fueling economic growth. These outcomes are really why we explore, and they're just as important as how we do the exploration. So let's start with the why. Let's go on to the next slide, please. And I feel certain that Jake Bleacher talked about some of this yesterday. But, when we started developing, or when ESDMD started developing the strategy for the Moon to Mars program, they really put an enormous amount of thought into why we explore. And broadly, of course, NASA explores for the benefit of humanity. But for Artemis in particular, NASA explores for 3 specific reasons, which are the pillars, really the foundation of the whole Artemis campaign. And as I'm sure Jake stressed and brought home yesterday, the first pillar is science. Science really does drive our exploration missions. And I can tell you, even in my short time in ESDMD, it's wonderful to sit in some of these conversations and hear leadership, senior leadership on the exploration side, talking about how we're making this decision or that decision because it benefits or doesn't benefit science, right? That it's part of the conversation. And it's really wonderful to hear that. Truly, science is what fuels innovation and social progress and ultimately improves our quality of life. And so it's that reason for science that we're returning to the moon, because the moon offers new opportunities for discovery that really are not available anywhere on Earth. And as some of us that are planetary scientists know, the knowledge that we're going to gather at the moon will also help answer enduring questions about our solar system, how it formed, how it evolved, and how the Earth-Moon system continues to affect life here on Earth. The second pillar is national posture. And this is really important. Artemis is all about collaboration, uniting many nations, private enterprise, and government agencies, all to make lunar exploration possible. Artemis continues NASA's legacy of working with our European counterparts on incredible projects like Hubble, Webb, and the International Space Station. And it's these partnerships, as these partnerships continue to strengthen these bonds among our nations and bolster our reputation on the international stage and contribute to humanity's shared knowledge. And of course, the final pillar is inspiration. And I know I spoke about this in Scotland, but truly this one really touches me, I think, in a very real way. You know, as children, we all looked up and marveled at the moon and the stars. And I know for you and definitely for me, that sense of wonder never diminished. In fact, definitely has grown stronger over the years. And it's exciting to think that the Artemis campaign will really reignite that same inspiration for the next generations that are to come. And Artemis will not only propel our humans to the moon and beyond, it'll propel humanity to overcome these seemingly impossible challenges. And so with that as our vision, I'm now going to kind of walk through where we are with Artemis and how we're all going to achieve it together. So we can go on to the next slide, please. So let's talk about Artemis campaign. I know there's a lot of emphasis and discussion about, you know, Artemis 1, Artemis 2, Artemis 3, and I'm going to talk about those individual kind of milestones, but I don't want us to think about Artemis as simply those milestones. Artemis is really much more than a collection of individual missions. It's a campaign. It's a series, an unbroken chain of these ever more complex missions where each launch is going to bring new capabilities for scientific discovery and exploration. Artemis is going to firmly establish the techniques and the infrastructure that are needed for the sustained long-term human exploration in space. Ultimately, what we're going to build and test and discover through Artemis will set us on a steady path, not just for sustained presence on the moon, but to help prepare us for that next giant leap for Mars, going to Mars. Next slide, please. So I'm going to step back for a moment. Let's recap. Let's go back to Artemis 1. I don't know if you were like me, you were up in the early morning hours of November 16th watching the NASA live stream when we successfully launched Artemis 1. Artemis 1 sent the uncrewed Orion spacecraft further than any crewed spacecraft has ever gone before. And 26 days later, that Orion spacecraft splashed down in the Pacific Ocean off the coast of Baja, California. The spacecraft was recovered and along with its scientific payloads was returned for study. And since that time, NASA's been analyzing every inch of the capsule to learn all that we can before we fly astronauts on our next mission. Next slide, please. Of course, Artemis 1 was also really important science mission, carrying 4 principal payloads that are shown on the left-hand side of this slide. Along for the ride was Commander Moonikin Campos, a male analog mannequin. The term Moonikin was chosen in a public naming contest, receiving over 300,000 votes. And Commander Campos was equipped with 2 radiation sensors and multiple acceleration and vibration sensors. And the results from those sensors are being used to help protect the Artemis 2 crew from all the way from launch to their safe return back home. Other secondary science payloads include experiments from NASA and many of our national and international partners. And beyond those core science objectives, these payloads are also helping us to learn how to fully utilize, how can we best utilize the science capabilities of this and future Artemis missions. Next slide, please. So Artemis 2, this is the next launch in this increasingly complex campaign, is scheduled for launch in September of 2025. Artemis 2 is going to carry 4 astronauts, including the first woman, first person of color, and first international partner on a lunar rendezvous and return, bringing them safely back to Earth. The 10-day mission is going to further test the Orion spacecraft's capabilities. Also going to conduct multiple physical and biological science experiments, including collecting critical data on human health to ensure we have the systems and architectures in place for crews to thrive in deep space. And I know I shared some of this at the European Lunar Symposium back in Scotland, but for those that maybe weren't there, I just want to share with you truly, I've in this new role, been able to visit some of the centers, in particular, going to Kennedy Space Center and seeing the hardware that's being built and being prepared, being able to walk through the room where there are the Orion shells for Artemis 2, 3, and 4 in various stages of development. The hardware is there. The development is proceeding. It's just spectacular. I also got to see the mobile launcher. The Mobile Launcher 1 and the early hardware for Mobile Launcher 2. Got to see the emergency egress system that's being worked on and upgraded and improved before Artemis 2. And other upgrades to the NASA ground support systems. Really just incredible to see the amazing amount of work that's going on in preparation. And as we prepare to fly, I just want to say safety is and will continue to be our top priority. Unlike the 1960s and 70s, we really aren't in a space race right now. We are truly in a united, collaborative journey of science and discovery in deep space. And I know it's been more than half a century and we're all really anxious for humanity to return to the moon. But I just really want to stress here that we will only fly when we're ready. And I'm sure Jake probably stressed this yesterday, and I'll stress it here again today. We will only fly when we are absolutely positive we can return our astronauts, our friends and colleagues back to Earth safely. Next slide, please. As we talked about, of course, one of the pillars of Artemis is science. And so Artemis 2 is going to include payloads and campaigns to study heliophysics, astrophysics, geology, chemistry, and human health. In fact, each crew member will wear a device called Archer, the Artemis Research for Crew Health and Readiness, which is going to collect data on sleep and wake patterns, on activity levels, and performance of operational tasks. A second study called Immune Biomarkers is going to examine space travel effects on the immune system. We're also excited for the opportunity to make direct firsthand observations from that region between Earth and the Moon and the lunar far side, the cislunar region, using our human astronauts for the first time in many decades. And above all, Artemis 2 is going to be really that final stepping stone to humanity's return to the surface of the Moon. Next slide, please. So let's talk about that. Artemis 3. Artemis 3, planned for 2026, is going to make history with the first woman to walk on the moon and the first human exploration of the moon's south polar region. Getting there, of course, is going to be a team effort among nations, as well as public-private partnerships. SpaceX is going to provide the human landing system for Artemis 3, the human landing system called Starship, which will transport the astronauts from Orion to the surface of the moon and back again. I hope, again, like me, you guys watched a couple weeks ago the successful flight test of Starship. They plan another flight test very soon, so the progress is really moving along on that human landing system. Before Artemis 3, SpaceX will conduct at least one uncrewed Starship mission to land on the moon. It'll also launch a storage depot, a fuel depot into Earth orbit. For Artemis 3, Starship will fill its tanks at that storage depot and then execute a translunar injection burn. Starship will then enter what is known as, you probably are familiar, the Near Rectilinear Halo Orbit, or NRHO. This orbit harnesses that balancing of gravitational forces between the Earth and the Moon, and it also provides access to multiple landing sites, including the lunar South Pole. When Orion arrives for Artemis 3 and docks with the Starship, 2 astronauts will transfer to the lander and travel to the lunar surface. The other 2 are going to stay on Orion conducting research from orbit. And just want to make sure I call out that Axiom Space is going to provide the mobility-enhanced Artemis 3 surface suits and spacewalk systems for that mission. Next slide, please. So the Artemis 3 astronauts are going to conduct an integrated field science campaign on the moon. This is what it's all about. We really want to get that integrated approach to science on the moon. This is going to include making geologic observations, collecting images and samples, deploying instruments, and understanding how the human body works in that exploration environment. The goal is to deliver generational science from lunar terrain that we have never visited before. The astronauts are also going to deliver 4 instruments near the lunar South Pole. 3 of these were competitively selected. The LEMS instrument package is a combined seismometer and mass spectrometer. It's going to study organic and inorganic molecules, including volatiles such as water and methane. LEAF is going to study how the lunar environment affects the germination and growth of plants. LDA will measure the regolith's ability to propagate an electric field, which is a key parameter in the search for lunar volatiles, especially ice. There's also going to be one strategically directed science payload, the ALLR, a laser ranger, which is a laser retroreflector, which is one of 3 identical instruments, with the other 2 going on CLIPS missions. Next slide, please. Following Artemis 3, the next kind of milestone along the way will be Artemis 4. This will be our first crewed mission to Gateway, the lunar space station that'll also be in the near rectilinear halo orbit. By the time Artemis 4 arrives, 2 modules will already be in place when they get there. Those 2 modules, the Power and Propulsion Element, or PPE, and the Habitation and Logistics Outpost, or HALO. The Artemis 4 mission will install a second habitation element called the International Habitation Module, or the Lunar IHAB. This module will be provided by our European partners at ESA, with significant hardware contributions from our Japanese colleagues at JAXA. It's one of 4 Gateway modules where astronauts will live and work. And while 2 crew members stay at the Gateway to continue their setup and conduct research and monitor ground activities, the other pair of astronauts will enter the Starship to conduct lunar surface science and exploration. For this mission, Artemis 4, the larger and more powerful version of the SLS rocket, known as Block 1B, and the associated Mobile Launcher 2 required to launch Block 1B, those are both also set to debut for Artemis 4. Next slide, please. So I mentioned the Gateway. As I said, the first 2 modules, the PPE and HALO, those will have already taken shape prior to the Artemis 4 mission. These modules will have launched aboard a SpaceX Falcon Heavy rocket, and they take about a year to get to their destination, relying on solar electric propulsion and gravity assists from the Earth, Moon, and Sun. The PPE is going to generate about 60 kilowatts of electrical power for Gateway's subsystems, and its solar electric propulsion system will maintain the station's orbit. The PPE will also support high-rate communications between the station, the lunar surface, and Earth. So you can see from this graphical diagram that Gateway will be very similar to the International Space Station, basically a hub for science relying on contributions from partners the world over. Next slide, please. So we're partnering with ESA and JAXA, and we already have selected 3 essential science instruments for Gateway to monitor radiation and space weather, which of course poses significant risks when living and working away from Earth's protective magnetic field. Research on the moon's surface will also shed new light on the sun by including studies of the historical record of solar activity as preserved in the lunar regolith. This will enhance our ability to understand and predict the sun-induced radiation environment experienced by astronauts exploring the moon and Mars and beyond. Next slide. So beyond Artemis 4, Artemis 5. Artemis 5 will be NASA's 4th crewed mission under the Artemis campaign. The mission is going to demonstrate the capabilities of a second human landing system, Blue Origin's Blue Moon Lander, and also include a lunar terrain vehicle. In addition, the ESA provided Esprit, a refueling module, and the Canadian Space Agency's Canada 3-arm robotic arm will be added to the Gateway. Next slide. So just to kind of talk about this for a moment, the addition of the lunar terrain vehicle, the addition of this LTV is really going to greatly improve the range that our astronauts can explore on the lunar surface. This means that we can conduct a more comprehensive field campaign, including collection of a greater diversity of geologic samples. And so this slide really just kind of uses Apollo as an example to really show the dramatic increase in both the volume of samples and the distance to the locations where the samples were collected as metrics for when the lunar roving vehicle was added to the architecture. So we really feel like this will significantly expand the science that can be achieved. The Artemis lunar terrain vehicle will have even greater capability than the Apollo roving vehicle. because the LTV will have an even greater ability to gather, transport, and protect samples. And it can also be operated remotely, allowing us to continue our work, to continue the science in between those crewed missions. Next slide, please. So beyond Artemis 5, the future missions are going to continue to expand our ability to explore, conduct science, and live and work on the lunar surface. Right now, we currently have hardware in production all the way through Artemis 9. And when I learned this, when I stepped into this role, that kind of blew me away. I was like, wow, we're already working and planning towards this whole series of missions to build this incredible capability for sustained lunar exploration. Artemis, is so much more than just boots on the lunar surface. It's really about this long-term exploration and utilization of the moon. I also am really pleased to say that back in April, the United States and Japan signed an agreement on the pressurized rover. This enclosed vehicle will be able to accommodate 2 astronauts on the lunar surface for 30 days and have a lifespan of about 10 years, enabling it to be used for multiple missions. And this rover also will be able to be operated remotely, so it can be positioned at the next crew landing site and be able to conduct research between the crewed missions. Next slide. So I just want to talk a little bit about the overarching, the architecture process, and I think Jake spoke to this a little bit yesterday as well. But how do we get here, and how do we make decisions on how to prioritize our investments moving forward? And really the answer is this overall Moon to Mars architecture. For any engineers in the room, you know that every architecture requires a blueprint, and that's where the NASA's Moon to Mars architecture comes in. It defines and ties together all the elements that are needed for this long-term, sustained human-led scientific discovery in deep space. As of today, the architecture consists of 4 segments. The first segment is really the human lunar return. These are our first steps, really the building blocks of what we need to explore at the moon. Beyond that is a phase of foundational exploration. And then beyond that is the sustained lunar evolution. And then ultimately beyond that, the jumping off point for humans to Mars. And so each of these increasingly complex segments builds on its predecessor and brings us to new frontiers of scientific discovery and human exploration. So go on to the next slide, please. And as we're thinking about Mars and what comes next, we're preparing for the moon, but we're also setting the stage to prepare for sending astronauts to Mars. And in order to get there, we need to make some pretty high priority decisions now, today, to help us be prepared. And just this year, we recently unveiled the first 7 of those key decisions, which address the critical why, when, what, who, and how questions of NASA's Moon to Mars objective. So why these particular 7? These particular questions either have the greatest impact on Mars architecture, such as the science we want to conduct, that could drive architecture, or they need to be made, these decisions need to be made really early on to allow for necessary technology developments, for example, for things like power. So that's why these are started, and I can tell you that teams are already conducting trade studies to help our leadership make the most informed decisions possible. Next slide. So I know I've talked about this already a little bit, but just want to stress again the importance of the partnerships, particularly our international partnerships are really key to the success of our Moon to Mars architecture and to human exploration in deep space. NASA is interested in international cooperation on every scale. We have partnerships that span from CubeSats to gateway elements to the pressurized crew rover on the moon and, all of our other Moon to Mars objectives. In fact, when you look at the architecture definition document, the international collaboration is the #1 recurring tenet that shows up over and over again and was drawn to the top of that list. In our Moon to Mars objectives. So space exploration is really just such an immense undertaking. We can't do it alone. And so I really encourage you to scan the QR code here to learn a little more if you're interested. Next slide, please. And so just to kind of wrap up, just to say that whether our destination is the moon or Mars, low Earth orbit or deep space, we all explore for the benefit of all. But in order to do that, we need your participation and support to achieve all these goals. As part of our architecture process, we want to involve the communities, whether that's international or commercial or industry or science. And for you to learn how you can participate, please go to the links that are provided on the screen here. On the left, you can see a QR code for our website, which hosts the current set of architecture definition documents, including executive summary and the white papers on relevant topics. On the right, you can see another QR code, which is where you'll find a subscription form for email updates about architecture events that you may want to participate in, including our next series of workshops that are planned for February in 2025. So with that, I'm going to thank you for your time. And when we get done with the session, when Gina's concludes, I'm happy to take any questions. Go Artemis!